Hello everyone, my name is Dhruv Patel and my project was regarding predicting ICU stay for patients based on Mimic 3 dataset. Now, first I'd like to introduce the idea of the project was to predict number of days a patient will stay in hospital, and it is important because hospital administration will know the need of beds in future. Insurance companies will know in general how many days their client stays at hospital so they can budget properly. And patient will know how much copay they need to pay. It will, allocate resources efficiently and reduce the cost. So that's why this problem is important. And in relation to the solution, what you're seeing currently is a dashboard where predicting based on lab tests and vital signs, and that results in the status like patient is likely to stay more than 1 day in ICU. So I'll get into details on how I'm predicting this particular part, like what vital signs are important, what lab tests are important. So let's get started on that. So first, I used machine learning models to achieve this particular dashboard, and I'm going to walk you through how part. So basically, this is a classifying problem where we predict whether a patient will stay more than 1 day, um, or they'll stay less than a day. So, first, to kind of repeat this exercise, I have deployed my code on GitHub where individual project CS6440 under my username, and you can actually go ahead and download it. Once you download it, you will open Anaconda Navigator, and I already did. I opened Anaconda Navigator. You run Jupyter Notebook, and you will get to this particular part where um, navigate to this particular folder and click on ML Mimic3 dataset.ipy notebook. Once you click on that, you will get access to uh, this particular Python notebook. Now, just walking you through on what did I consider. So first, I loaded necessary libraries. Then I loaded the dataset. Now, how did I get to this dataset? So first, what I did is, and you don't have to do this, by the way. You have to create an account on GCP, Google Cloud Platform, and navigate to BigQuery, where you will particularly write this SQL query that I wrote, like Mimic3 GCP query.sql, to get this particular data set. But good news, the data is already existing in mimic3 underscore data.csv, so you don't have to go through that. So cool. Now I'll be walking you through Mimic3 data set. I loaded the data set, then I did exploratory data analysis where I said, okay, what is the length of stay for all the patients in Mimic3 dataset in ICU? And I got their mean, median, and standard deviation. And since the distribution, as we see down below, is not normal, I've decided to go with the median ICU stay. So that's where the split happens. I basically say, I basically determine a lot of patients need less than a day, um, or yeah, on median, a patient will stay about 2 days in ICU. So to determine if they stay 1 day or more will be efficient to classify. And I'm going to show later how I got great results, 80% accuracy by using some machine learning models. So I'll walk you through with that, but later on. So yeah, only included numerical columns and important columns. So like ethnicity and race is kind of uh, omitted from the data, and yeah, cleaned up the data a little bit. Then what I did was I split our data set into training data and testing data, regardless of the dates. So 30% data is testing data, 70% data is the training data, just to get a better model when the new data set comes in. So then I created AUC and ROC curve baseline model. As we can see here, I used 5 different algorithms: MLP classifier, decision tree, k nearest neighbor, SVC, which is a super vector machine, and a gradient boosting classifier. And it turns out this is our baseline model where the hyperparameters are not set. So yeah, this is the default parameters that are provided in the scikit-learn. Now, we see that gradient boosting classifier serves the best. However, no hyperparameters are set. So next task is to set particular hyperparameters. And when I say hyperparameters, it will be for, let's say, MLP classifier, it will be how many number of hidden layers. For decision tree, what would be the depth or a leaf size. For k nearest neighbors, what is the k nearest neighbor? So I determined that value of k in k nearest neighbor. For decision tree, number of leaves, the maximum depth, and for MLP classifier, I determined number of hidden layers. So looking at the learning curves, as we see, for the first one, we are looking at the MLP classifier, and we see there's like a huge, kind of variation. So this might not be this might not be as accurate as we see because there's a lot of fluctuation with the MLP classifier, and yeah, and looking at the decision tree, we see this is clearly not, since there's a large gap between. So this is not a great model to use and work on. K nearest neighbor, again, including bias variance trade-off. This particular KNN nearest neighbor is performing worst on the testing data. So, and looking at SVC, it performs better, but again, the training data set has a high error, but the testing has low, so this is also kind of not valid. While looking at gradient boosting classifier, we see that this is actually working perfect. As we increase the training data set, testing data set error gets decreased. So this is actually a perfect model. When the new data comes in, there won't be any bias including in it. So cool. So then this code is mostly about tuning. So as we see here, hidden layers, I chose 10, 10, 50, 50, and 100, 100. And we see that for optimal solution for the testing data, we get our best performance at 50, 50. Yeah, and also maximum iteration for neural nets as well. And alpha level, which is a learning rate, we kind of optimize our hyperparameters right here. Tuning with decision tree and KNN and gradient boosting. Out of all, gradient boosting is super important. And in the improved models, as we fix the maximum depth to be 7, we see that gradient boosting performed very well compared to other 2 algorithms. I decided to not include MLP and SVC because it was taking huge amount of computational time. So as we see, this is also visualization for each, like in representation of tree, and then the data is exported to the model result.csv, which can be found also here as well if you go under my project. Yep, model result. Cool. And then after I created this particular dashboard,